Hello and welcome to the MRC Millennium Medal 2021. Fantastic. I feel we should almost run that again just to make ourselves just feel great about being together. So for those of you watching this from home and online, we have a rabble here of enthusiasts, supporters and cheerleaders of the MRC in this room at the Royal Society. My name is Vivian Parry. I'm a science writer and broadcaster. I couldn't be more pleased to be here with you today. I've been on the council of the MRC. I sat on the board of UKRI, and the MRC and all its works has been very, very dear to me. And medical science is a thing that has propelled my whole life. So I'm thrilled to be with you today. Now, because we're all together for the first time, we are going to have a bumper event today. That sounded a bit boosterish and Boris Johnson, didn't it? But we are going to have a magnificent event today. We are going to have, first of all, the presentation of the MRC Millennium Medal 2021 to Professor Sharon Peacock. She is also, there's going to be lots more of that. She is going to deliver a lecture and you'll have an opportunity to ask questions afterwards. Then, there's more. We are going to get the presentation of the MRC Millennium Medal 2020 to Professor Sir Rory Collins. So Rory really did miss out a bit last year and had to do everything online. So this is his kind of moment of in-person glory. So we feel that we need to give him that. And then finally, there's still more. Yes, there is a new medal, the annual MRC Impact Prize, which is going to be introduced to us by Dame Ottiline Lyser. So we are going to start off the evening with Professor John Ardale, who is going to tell us a bit more about who is going to win the medal and why.
Great, wonderful. Thank you, Vivian. And it is truly wonderful to see everybody here. And I hope you've all enjoyed, as the token liver doctor in the room, just one glass of wine before coming in. Although from the noise I'm hearing already, I'm worried that some of you may have had a little bit more. So first of all, let me express my sincere thanks to Vivian for agreeing to come and introduce this evening. As many of you know, Vivian is an award-winning science writer and journalist, head of engagement at Genomics England, and we've been delighted that she's accepted the invitation. And Vivian, thank you for agreeing to be Master of Ceremonies for this evening. You've already laid out the timetable. I think you're going to be quite busy.
And I wouldn't miss this for the world.
Anyway, welcome again to the MRC Millennium Medal competition. So the Millennium Medal was inaugurated in 2000. It's the MRC's most prestigious prize, and it's awarded to an outstanding MRC-funded researcher who demonstrates scientific excellence and impact, as well as an individual who improves the wider research environment and the wider research culture. Since its first launch now 20 years ago, the Millennium Medal has been presented to 9 truly outstanding individuals. We've seen several of these researchers go on to receive a Nobel Prize and be listed in the Queen's Honours for scientific excellence in their given field. The winner receives a prestigious medal cast in silver by the Royal Mint, and they will be listed amongst the most highly influential and impactful researchers in the UK just by virtue of receiving this prize. In 2020, the competition was opened up for nominations for universities and for research organisations to recognise their outstanding researchers who meet MRC's vision of improving human health via their world-class research. So this year we received 18 nominations across 13 different institutions from the complete breadth of the UK. The nominations truly represented this enormous depth and breadth of science that we have in the UK and that MRC fund, from leading advances in epidemiology and social science to diagnostics and biotechnology. As well as impacts on combating COVID-19, it was clear that the scientists involved and the scientists nominated truly were world leaders and were recognised nationally and internationally. So it won't surprise you that judging this year's competition was extremely difficult. We charged our judges with using a series of criteria. The individual had to demonstrate scientific excellence and a strong international reputation, demonstrate a very clear scientific impact, demonstrate a commitment to improving the wider research environment and culture, and make an outstanding contribution to the mission of the Medical Research Council. As I say, you will appreciate, given what I've told you, that it was a particularly difficult job reviewing and selecting the winner of this year's prize. And it's important, I think, today to recognise the real excellence of all of the applications that we saw. But it was quite clear that there was one winner, and the emergence of Professor Sharon Peacock as the deserved winner. Sharon is Professor of Public Health and Microbiology at the University of Cambridge. She's Executive Director of the COVID-19 Genomics UK Consortium. Many of you will have heard that referred to in the press as COG UK, and a non-executive director of Cambridge University Hospitals Foundation Trust. So Sharon prevailed against this extraordinary competition, and it really does attest to her scientific excellence, her extraordinary leadership, and her very, very clear commitment to training and supporting the lives and careers of others on her own, as she's gone on her own remarkable career journey. So we award Sharon this medal on the basis of the broad contributions across medical research that she has made. She is a world-leading pioneer and an advocate for applying sequencing to public health and infection control, which has had a profound impact on national and international policy. In March 2020, Professor Peacock took rapid action to initiate and direct the COVID-19 Genomics UK Consortium, COG UK, which was key to monitoring the emergence and spread of new variants of SARS-CoV-2 at local, national, and international levels. Throughout her career, Sharon has made outstanding contributions to advocate for and advance equality, diversity, and inclusion in research by establishing the Woman in COG network. So I would like now to welcome Professor Sharon Peacock to the stage to officially present her with this year's MRC Millennium Medal and to offer big congratulations from all of us at MRC, and actually, Sharon, all of us in the research community, on your incredible achievements. So I'd now like to invite Sharon to share a few words with us on receiving the medal. And then afterwards, Sharon, if you'd be kind enough to give us your award lecture, which you've entitled, Bringing Pathogen Genomes to the Masses, My Science, My Legacy. Sharon Peacock.
Well, thank you so much for that really kind introduction. So I'm really moved by this event today. How could I not be? And I'm really delighted to be able to tell the story of pathogen genomics, actually, how I played my part in bringing this into the heart of the pandemic response, but how we as a science and public health community really delivered SARS-CoV-2 genomes to the UK, but actually beyond that. So this effort has been much bigger than me. I want to start by paying tribute to my research group in Cambridge, who began more than a decade ago to generate a groundswell of evidence for the impact of pathogen genomics in public health and healthcare, and, importantly, to the 600 people who are the COVID-19 Genomics UK Consortium, or COG UK. I also want to thank the COG Steering Group and External Advisory Committee, together with the incredible administrative team based in Cambridge and led by the talented Katerina Galai. You can't run a consortium of 600 people without very strong underpinning. I want to also acknowledge with gratitude Sir Patrick Vallance and Sir Chris Whitty, who actually understood the importance of genomics very early and provided access to the necessary funds to get COG off to a flying start. So on reflection, I still feel a sense of surprise by what has happened, not least because I didn't ever anticipate that the words genomic sequencing and variants would ever become everyday vocabulary of the public and policymakers. But actually, COG UK really has helped to show the way. So COG UK has also allowed us to highlight the role of women in science. The pandemic has really taken a significant toll on the well-being and energy of so many people. And we wanted to highlight women who radiated positive energy and who changed the world around us during the pandemic. So we are growing our library of voices, which collectively allow us to frame a narrative about what women can do and their rightful place in the world. Now, just to echo previous comments from Vivian, the MRC has been absolutely incredible. I really can't say that loudly enough. They administered our COG UK funds and helped us with huge integrity, wisdom and kindness. And special thanks go to Jonathan Pearce and Anna Kinsey. Prior to the pandemic, the MRC actually funded my genomics for well over a decade, and I've also worked on numerous MRC panels and boards over the years, and I've seen their work and dedication from the inside, and I'm really ever grateful for their presence in the UK science landscape. Thank goodness for MRC. So my closing comments return to the person standing before you. I actually want to acknowledge that awarding me this medal is a reflection of the power of higher education to change a life. Many of you know that I left school at 16, but through education I discovered my inner strength through study of medicine and medical science. This allowed me to be creative and innovative. I worked along some great people, including many people in this room, and had fantastic company. I travelled the world, and what is not to like about that story? But most important of all, I do want to give my thanks and love to my husband Peter and my 3 children, Kat, Rob and Bex, because they are my greatest supporters. Thank you. So now I have the joy of talking about genomics for 25 minutes. When I was asked to give a talk for 25 minutes, I thought that's 25 years in 25 slides over 25 minutes. That's not a bad thing to try and do, but I'm really looking forward to talking about genomics. Now, I don't know if you know, but today is, in the United States at least, the National DNA Day. It commemorates the discovery of the double helix in 1953 and the completion of the Human Genome Project in 2003. And so this is a fantastic day to be standing here talking to you about genomics. So you know the title of my talk, and I'm going to give you a sense of what I'm going to talk about. My talk is going to be split into 2 halves. The first is what happened before the pandemic. Why did I go into genomics? And I'm then going to talk about applying genomics to outbreaks and infection prevention and control, or IPC, as I'll abbreviate it. I then want to form a bridge to the pandemic to describe the runway that we had in this country that led to pathogen sequencing. We didn't know it at the time. We were absolutely poised to do a best job in pathogen sequencing for SARS-CoV-2 when it came along. I'm then going to go into the pandemic and talk about COG UK, COG Train, which is our training arm, and women in COG. Now, going back to 2003 to 2009, I was actually working at the Mahidol Oxford Tropical Medicine Research Unit based in Thailand. Now, I was studying diseases of the rural poor, which are common there but not here, including melioidosis, a bacterial infection, leptospirosis, and scrub typhus. But in 2009, I decided to come back to the UK, bringing my 3 children and my husband with me, and really had to think about what science I would entertain. And I couldn't bring my current portfolio back with me, so I had to reinvent myself as a scientist. What I realised was that there was both opportunity and serendipity in the decision that I would need to make. I was offered a chair in the University of Cambridge in microbiology, and that, of course, is very close to the Wellcome Sanger Institute. But there was something else about this story, and that is that really in 2009 we'd reached a tipping point for pathogen sequencing. Now, sequencing costs have plummeted. So the first pathogen genome, and Julie and Parkhill in the audience will know a lot about this, the first pathogen genome cost about £500,000, and it took 18 months to do. But now we can do it for about £50 in a couple of hours. So even back then in 2009, it was clear that sequencing cost was coming down, and we might be able to start using this for clinical practice. The speed and quality, the quantity of the genomes that we could actually also produce, we had a real flexibility in instruments that we could use, from a handheld device that would do a couple of genomes or one genome, right the way up to very large instruments that could do very high scale sequencing. But what really grabbed me was the fact that this could have clinical feasibility. So these instruments were easy to use, and they had a rapid turnaround time. So I was looking for impactful applications. How could we use this for clinical practice? And I'd like to thank right now Gordon Dugan and Julian Parkhill, who were working at the Sanger at the time, and they helped me on this journey into clinical pathogen genomics. Now, in pathogen genomics journey, I've got 2 main strands. One is antimicrobial resistance, and I've done a lot of work on that, but I'm not going to talk about that, other than to a shout out to Catherine Nudden and Theo Gulioris, who really led that piece of work. But what I'm going to talk about now is outbreaks and how we use sequencing to improve outbreak detection and management. Now, we have to go back to understand how we manage outbreaks or investigate putative outbreaks to 1854. The map you see here is going to be very familiar to you. It's the map that was drawn by John Snow, who, as you know, was the father of modern epidemiology. And what he did was he plotted the cases of deaths from cholera in 1854. And having done that, he realised that this was a waterborne disease and suggested that the pump in Broad Street, the water pump, was to blame, and the handle was removed from that pump. Now, what you'll see here is the epidemic curve of deaths. By the time he took the handle off, the epidemic curve was already peaked and coming down again. Nonetheless, this paradigm of going door to door, finding out who's got disease, plotting it out, and looking at cases and their relatedness is what we do today. And as I say, this is really referred to as shoe leather epidemiology. Now, come up to 2009 when I was thinking about genomics, and actually we do pretty much the same. If we look at hospital outbreaks, we go through a process of surveillance. So we have a daily list of patients with indicator organisms, perhaps MRSA. If 2 cases are positive for the same indicator organism, you look for overlaps in time and place. And then if it's a positive on that, you go and investigate them. You go to the ward and you say, is an outbreak happening? Now, at that point, you might use bacterial typing, but not very much. It's used as an afterthought, and that's because pre-2009, the typing we had was very poorly discriminatory, had a slow turnaround time, and it invariably didn't add much extra information. So after your investigation, you would then take actions to contain further spread. Now, there's a couple of problems, at least with this paradigm. First of all, if you think about your house burning down, what you want is a smoke detector to detect the first whiff of smoke, rather than realise that your house is burning down and you have to call the fire brigade. And I liken infection control to this, because what we want is the first sniff of trouble when the first 1 or 2 cases start in an outbreak, rather than letting it rip through a ward or a community and then realising that there's a real problem. And we also needed to really capitalise on emerging technologies. Now, what I'm going to do is talk through a series of 6 studies which really capture the whole pathway of what we were doing in outbreak detection and control, focused on MRSA. We studied other pathogens, but I thought that I'd focus on one pathogen. And in the top right, you can see some of the incredible scientists who were working on these projects. Now, the first thing we did was really simple. We published this in the New England Journal in 2012, and what we did was we provided the first use case of benchtop sequencing to identify hospital outbreaks. It was a very simple study. We had 11 people who had MRSA, and sequencing, previous typing, they were all, you couldn't tell these cases apart. Sequencing identified 7 people in the outbreak and 4 people not. So that was really useful, and that gave us a first inclination that sequencing could also tell us things like a genetic prediction of antibiotic resistance. So it worked. The next thing we did was to actually use sequencing to pit it against infection control, and also see if it actually led to an impact, because retrospective sequencing is all well and good, but can you move the dial in terms of impact? So we were based in Special Care Baby Unit in Cambridge, and there was a cases of MRSA in the Special Care Baby Unit that ran over 6 months with quite large gaps in time in between. So infection control said this is not an outbreak, and sequencing said yes it is. So we already knew that this was better than infection prevention control alone. But what we then went on to do was actually uncover what I would call dark matter of an outbreak, people who've got MRSA that you didn't realise was connected to the outbreak. So mums, dads, etc., all linked back to this outbreak, even if they really presented a year later. So the forensic epidemiology that we can add to this through sequencing is quite remarkable. But then what we did was we ended the outbreak by screening staff, realising that one of them carried this particular strain, and actually removing them temporarily from the workplace whilst they were decolonised. And so this was the first case of really sequencing changing clinical practice. So that was a great study, but the disappointment was that if we had sequenced the first 2 or 3 cases, we would have known there was an outbreak. And instead, it had to continue when more babies were affected. So what we wanted to do was to say, if we sequence every single MRSA isolate and try and put the genetics together right up front, we might be able to see something that we couldn't see previously. So we conducted a prospective cohort study over 12 months, and that was based at Addenbrooke's Hospital. We were in the micro lab there. And that lab gets samples from 4 hospitals and 75 GP practices. So over a year, we recruited around 1,500 MRSA positive patients and sequenced at least 1 MRSA isolate from them. We did the genetics and the epidemiology, and what we found was actually quite surprising and shocking. At least 40% of those cases were linked to 173 different clusters or putative outbreaks. And those outbreaks range from a small 2 people to 44 people. So we were clear that sequencing was far better than just watching people move around wards who are MRSA positive. And what we then did was we started to hypothesize that sequencing first would allow us to get on the front foot, compare the MRSA isolates, and then do the epidemiology later, so it flips it on its head. Now, if we're going to use sequencing in clinical practice, and I very much hope that we're not far away before we can do that, we need robust genetic relatedness cutoffs between isolates. So if we have 2 isolates and you say, are they related enough to be associated with an outbreak or not, we needed a cutoff to rule them in or out of an outbreak. And we achieved that, published in Lancet Microbe, just around the time of the beginning of the pandemic. Now, the last icing on the cake, which is unpublished, is we've done another year study where we've analysed the same data, genetics and epi, in a fully automated system, and we've looked to see if this changes infection control practice, and it does. So this is really exciting because this is very close to being able to be translated into the clinic in real time. Now, I've talked a lot about the work that my group did, but going back to the rest of the country, by 2019, we really were ready for the pandemic, even if we didn't know that we were. Other groups, extensive groups actually, have been doing quite similar work to this. And there was dispersed expertise and capability in UK public health agencies and the universities. Not only that, there had been major investments and development of specific capabilities. And I want to talk about CLIME, which is the cloud infrastructure for microbial bioinformatics, which was MRC funded, and actually was really key because that formed a place where we could store our genomes. There are a great many people to mention, but certainly Mark Pallen, Tom Connor, Nick Lohman, and Andrew Page were critical to that. The Arctic Network was a network of sequencing methodologies, and then, of course, the Wellcome Sanger Institute. Now, finally, in our preparation, people had practical experience of recent outbreaks, so they'd been sequencing in Ebola and in Zika. So we were ready. However, perhaps we weren't quite ready for what happened in March 2020. March was a busy month. Now, in this figure, what you'll see is a timeline from beginning of March to the end of March and the 1st of April. In the red blocks here, you see the number of confirmed COVID cases in the UK now, accepting that we had limiting testing capabilities, but this was the actual number that were confirmed. Underneath are the green blocks of the genomes that were sequenced of SARS-CoV-2 during that period of time. Now, what I'd like to do is really point out 3 facts. The first is the incredible initiative that scientists took to get a sequencing capability off the ground. So on the 4th of March, following conversations with Sir Patrick Vallance, scientists were ringing each other saying we've got to set something up. By the 11th of March, 20 of us were clustered at the Wellcome building on the Euston Road. And what we did there over the course of the day was not compare lovely data. We talked about the blueprint of where could we sequence SARS-CoV-2, how and when. We then took, the second point is we then took that to Sir Patrick, who was able to fund us to the tune of £14.5 million to get us off the ground. And at that point, Sir Mike Stratton had agreed to lend the support of the Wellcome Sanger Institute with their in-kind contribution. Now, the last part of this is rapid action. So we have initiative, funding, and then rapid action. And that rapid action was really critical. We had a lot to do to get sequencing up and running, which I'll talk about more in a moment. But we had our first report to SAGE by the 23rd of March, and then COG formally began on the 1st of April. Now, one of the things I'm really proud about is that this was a 4 nations approach. We appreciated the importance of the 4 public health agencies in the United Kingdom. So we had the 4 public health agencies, the Wellcome Sanger Institute, and 16 academic universities, which you can see here, and that was so important. And we had a consortium agreement that bound us together with a data sharing agreement. And also, we had a publication policy, so everybody who did work in COG UK got recognition on the papers that came out of that. So I think that this was an incredible initiative, and it's the first time, actually, that genomes were shared between the 4 nations in such an easy way. So what we ended up with was actually an exemplary response. We weren't the first people to sequence SARS-CoV-2. That was done by Chinese colleagues together with Eddie Holmes, which you can see in these panels up here. And that was really important for vaccine development. But what we did was we were among the first to develop a capability to generate SARS-CoV-2 genomes at scale and use it for public health impact. So the UK really showed beyond any doubt that sequencing generates actionable information that supports an effective response, including vaccine design, vaccine redesign, thinking about the emergence of variants and variants coming into the country, etc., which I'll talk about a little more now. Now, I'm going to talk about the work of the consortium, and I'm going to divide it into 5 different timelines. It wasn't entirely this neat, but what I want to do is divide it up into 5 times and say, not what we did, but what we achieved. What was the output and impact of what we did? You'll see here the very familiar graph of number of cases over time, up until the end of 2021 largely, and then, as I say, the genomes we created over that time, and then these 5 different categories. So in our very early part, our launch period, this was really very busy, and over April and May, we reached 20,000 genomes. So we had to organise sample collection, operations and logistics. For example, we had to connect over 100 NHS testing labs to the regional labs. So the regional labs did all the sick patient testing or sequencing. And the Lighthouse labs were connected to the Wellcome Sanger Institute, who did all of the sequencing for the Lighthouse. And we estimated to have done about 10% of all positive cases. We had to refine our methods. We also had to link the genome data with the person data. Who has it come from and at what point? And in addition, we needed to develop the analysis tools. Now, this is our first impact slide. And it's really to say that our tools that we created underpinned the effort in the UK, but also elsewhere. So we have the sequencing methods, which I've already talked about from the Arctic Network, the Pango lineage nomenclature, which was devised by Andrew Rambo and his group, and then numerous bioinformatic tools, many from Andrew Rambo, David Robertson, and Nick Lohman and others. So we produced these and made them available, and all of our genomes were made available through the global database GISAID. Now, what about the next phase? I've called that Delivery 1, which is between June and November 2020. By then, we had produced 50% of the global total of genomes in the global database GISAID, 100,000 genomes. Now, at that point, the genome data that we provided to the public health agencies had been used in more than 120 retrospective and live outbreak investigations in the UK. Now, we wanted to share our science, and our first science showcase was viewed by 62,500 people. We started to think very seriously about the analysis of mutations and what they mean, and also importations. And so this wonderful piece of work in this graph here by Louis Duplessis, published in Science, really looking at what happened in that first wave of importations into the UK. Now, this study took all of the genomes available from COG UK and from the global database, about 50,000 genomes at the time. And what they did was they modelled and also evaluated the genomes to say, where have these come from? Now, I remember at the time we were worried about importations from Asia, from China, from northern Italy. But the data said something else. What was found was that there was more than 1,000 independently identifiable independent UK transmission lineages coming into the country. Around a third from Spain, around a third from France, some from Italy. And actually it really changed over time. And so this was really important in thinking about where the introductions are coming from. We'd only sequenced around 10% of isolates, but this explains that if you have more than 1,000 different introductions, why the country lit up, more or less at once, in March. We were also thinking very carefully about mutations and what these do around transmission, disease severity, and immune evasion. So the next phase is the alpha variant, which we've called the Grinch variant because it definitely stole everyone's Christmas. So between December 20 and February 21, we'd reached about 200,000 genomes, and this was, as you know, the first variant of concern. Now, it didn't really start to become apparent until end of November, beginning of December, although when we look back in our database, we could see the first genome on the 20th of September. This was a big surprise because it had a lot of mutations, 17, and that's why it led to the hypothesis that this had arisen in somebody who was immunocompromised and couldn't actually get rid of their infection. Now, it's history to say this was more transmissible, it had increased risk of hospitalization, but at that time, no significant impact on vaccine efficacy. And we provided the genomes that underpinned that information, that allowed people to do those studies. And I've listed a few studies with which we were associated. I didn't win any brownie points in December because I actually decided towards December that we'd worked quite hard, and I sent an email out to everyone saying, you can run down a little bit over Christmas, let's have a little time off. And let's have a skeleton staff. Well, that was the wrong thing to say. And by the 20th of December, I was writing to everybody saying, can you all come back, please? So true to life for the Grinch variant. Now, on to the next phase, really, Delivery 2. You can see the dates there. By then, we'd generated 500,000 genomes. And during this period, we really focused on doing more, cheaper, quicker. So on the left-hand side, you can see the number of genomes that we're producing going up over time. And on the right, the estimated average sequencing cost for SARS-CoV-2 genomes, reagents only. So there was a 40% reduction in costs. And this is, of course, taxpayers' money. Now, if we look at turnaround time, initially it was quite long. Too long for many people. But actually, when we looked at the turnaround time by the end of this period, by the time a sample got to a sequencing site and we got the data into our CLIMB database for analysis, that was between a median of 2 or 3 days, which I believe is very short. So the last phase I'm going to describe is the Delta variant. Again, this is a rerun of my previous slide in many ways. It was more transmissible than Alpha, except that this had partial immune evasion, most notably to the first dose of vaccine. And by this time, you can see the kind of characteristic waves of variants as they replace the last variant and actually sweep across the country. In terms of publications, by this point, our consortium was producing a lot of the scientific evidence that underpinned SARS-CoV-2 genomics in the UK. Now, before I move on, what I want to do is actually have a really important footnote to this story, and that is about linking genomes to other data. Now, during the pandemic, we had the SARS-CoV-2 genomes data, which was linked to the sample data. Where does it come from? What date? That would go into public health agencies and would be linked to the NHS number so that they could do very detailed analysis. They would analyse variants, but they would say, have people had vaccines? Have they had infections before? But this is, I think, the next frontier, what's happening next. So through funding from the National Core Studies, this particular stream is led by Andrew Morris. We are analysing genomes by adding extra data on top of that. So through the Outbreak Data Analysis Platform, which is based in Edinburgh and led by Kenny Bailey, there's a large collaboration where the viral genomes are being linked with human genomes, demographic data, electronic health record data, and data, for example, from REACT, from biobanks and so on, are coming together. And we may talk about this more later because I think that this represents yet another frontier for us to say, we have the pathogen genome, we have the host genome. If you put the two together, what magic can we make from doing that? So if you want to read about COG UK, we commissioned RAND Europe to undertake an independent evaluation of COG UK. You should never mark your own homework. So you can read about what we've done there. So I'm going to talk very briefly about CogTrain. Now, it's incredibly painful to realise that we were doing well, but other people were having trouble delivering genomes to their populations. And there's all sorts of reasons why that happens, funding, expertise, equipment use, etc. And so we decided to actually focus on training to try and help other people. This is a separate grant funded by Wellcome and the FCDO. And what we've done is develop a training program on how to sequence SARS-CoV-2. So we have developed online courses, virtual classrooms and train the trainer, and remote classrooms, all of this really developing an online learning community to increase our understanding and capacity for genomics. Now, what I would say is that this is an incredibly important collaboration with Wellcome Connecting Science, and I'd like to mention Teresa Krivin here, and an incredible ability for us to all work together. So we've already released our first online course through FutureLearn, and we're just about to release our second. I've mentioned there we've got remote classrooms in Asia, Africa and Latin America, and also more extended courses in bioinformatics in those same regions. So I'm very proud of this training programme. Now finally, women in COG. So my sense during the pandemic was actually the dial on us thinking about equality, diversity and inclusion was turned down. The reason for that is we were all in a hurry to get the job done, do what we needed to. But when I looked around at the consortium that we'd built, nearly all of the PIs were men. And I felt very uncomfortable about that myself. So we developed Women in COG. And what we've done recently is we've interviewed women who've really changed our world. And you can see some of the women there, but you'll see these women are highly influential in their own right and have given fantastic interviews, which are on our YouTube channel, actually. So these voices are really important in saying what it's like to be a woman in science, but also really shouting out that women have been incredibly influential during the pandemic. We're going to try and keep that information alive. So we're developing a book, and that book is going to have women who all worked in COG UK. We ran last year an Unsung Heroes Award where people who were working in the laboratory who don't have any visibility could be nominated. They are going to go into the book together with our interviews to last hopefully in perpetuity to say what people did. Now, finally, thank you. Now, I hope that my talk in general has actually acknowledged other people. I can't say thank you enough to enough people. But I would thank the funders. Going back to the MRC, they have been absolutely tremendous. We also got funding from other people, the Department of Health, Test and Trace, etc. And these people, I won't have time to individually call them out, but each of these people on this screen have actually contributed to our success. And I'd like to thank all of them. Now, I've talked about COG management advisory and steering groups, and again, these people have been instrumental in us succeeding. And so I'd like to thank all of those people as well. But finally, COG UK. Not only COG UK, which is mentioned here, but their families. You know, families are really important in this too. So thank you to COG members, thank you to COG member families, and thank you very much for listening to me today. It's been an honour and a privilege to talk to you.
Sharon, that was simply wonderful. And isn't it a wonderful story? It's something that you could write and almost nobody would believe you because there are so many different elements in it that have been brought together. I mean, you highlighted the way that actually the MRC funding in some really basic sciences and infrastructure made that runway possible.
Yeah.
You've highlighted the way that people came together. One thing you slightly glossed over, and I'm going to pick you up on, was there was a slide there where it said something like email to people, but it was you that sent out that email.
Yes, it was actually, yes. It's
yes,
true.
she's not going to get away with that.
Yes.
It was you that sent out that email. So there was a prescience about it. And what made you think, I must get this done?
Well, if you've worked in pathogen genomics long enough, you know that the virus is going to change at some point. It's not a question of if, it's a question of when. And so I wanted to do something, but I also wanted to check with other people. So on the 4th of March, I wrote 5 emails to people, colleagues who I trusted, at least one of whom was in the room. And I said, look, can you call me this afternoon? And at that time, you know, receiving lots of calls every day. And so I had a conversation with those 5 people. And I said, look, I want to test something out. Can we set up a kind of national sequencing capability? And everyone was supportive. So yes, I did then write to a wider group of people when we brought everyone together at the Wellcome Trust, and I chaired that and organised it. So yes, there's this kind of tension in that everybody else creates the output. And so I think that I feel slightly uncomfortable saying, I wrote those emails and I organised that, but it's true, actually, that I did.
It is true, and note that everybody responded. And actually that says a great deal about you as well, that all of those people, the minute they heard your clarion call, they were round.
And I was very grateful. And I think it was a combination of the urgency of the problem, but also the fact that we're a really good community in the UK. So people who do genetics, I mean, there's an incredible sense of collaboration. And so it's very easy to reach out to people and say, I've got something I really want to ask you. It was actually quite high risk at the time because there were colleagues who were saying, you know, you're wasting your time. The virus isn't going to change that quickly. You don't need to worry about it. And even on Twitter, I mean, Twitter can be quite a difficult place, but people were saying, no, you don't need to do that. You're wasting taxpayers' money. And, you know, very, very early on, We weren't making brand new discoveries, but what we were doing is we were embedding ourselves. We were learning how to look at this data, how to analyse it, how to do the sequencing, how to move samples around. So we were ready. I don't think we would anticipate exactly when alpha would emerge, but actually that was the difference in many ways between the UK, because actually we kind of took a big gulp and just did it, and other countries that waited for alpha to come along before they thought, well, better start to sequence now. So that was key, and I would lie in bed at night thinking, what have I done? And I'm sure other people did that too, but it was the right thing to do. And my view was, if the worst we've done is produce lots of interesting papers, well, that's okay. If the best we do is to prepare the country for sequencing, well, all good us, really. So that's how it went in my mind, really.
So I bet you cheered when you saw that first change.
Well, I didn't cheer about alpha, but I think that over time and looking back, it's clear that what we did was the right thing. And I think that's the thing with the pandemic. It's often looking back when you realise, oh, that was right, but that could have been done better. But I think with sequencing, looking back, we did the right thing in setting things up quickly and providing the information to public health agencies who could go in and actually dive in and actually add their own very precious information and make sense of things like outbreaks.
Now, if you have any questions, and if you're watching online, your questions can come through to us through Mentimeter. So you just put in and you'll see that the code is up there, and we'll get, magically, your questions will appear here. But meanwhile, you brought all these people together, and it's very, very striking the number of women that are involved in this. It's not just that there are a few women. I don't know what the percentage is, but perhaps my feeling is 60% are women.
Yeah, it's difficult to exactly put a figure on it, but for me, in the very first instance, in that very first meeting in the Welcome, I reached out to the people that I knew, trusted, and could come and do the job. But actually, over time, we have worked really hard to ensure that. I mean, often women will be working in the background, but what you won't necessarily see is them coming to the foreground. So what we tried to do was actually bring them to the foreground so that they were visible. And the work of women has been instrumental in sequencing, but the work of technical staff in general actually was really important. And I think often technical staff don't get the credit they deserve for the work that they do because they are actually producing the genome. So I think that's really important to say today.
But there's obviously something about the way that you involve women that's made it comfortable and made them feel that they can really flourish in that environment. What particular things do you attribute that to?
I'm passionate about women in science, and I'm not afraid to say so. Actually, I think if women don't speak up, then we've lost a trick, really, because if you don't speak up, people actually won't come to the fore. So for me, mentoring and making sure that women are kind of, their contribution is noticed is really key. I think the more we can talk that up, and that goes across the board, across equality, diversity and inclusion. We must always say something. And people, I was in a talk recently talking to people, and they said, well, how do you speak up? I think you have to learn to speak up. I've got to the age now where it just comes out of my mouth, and I can say, well, where are the women in the room or whatever? But
you're about to wear purple and spit and not care.
So yes, I think you get to an age where you think, well, I've got to say something. But I would encourage everybody, and it's a bit like infection prevention and control went through a revolution when we invited patients to ask their carers to wash their hands. Have you washed your hands before you touched me? If everybody was able to speak freely in meetings to say, have we got really good representation, then perhaps the dial might move. But you also have to remind yourself all the time. You have to have kind of like a sticker on your fridge saying, think about equality, diversity, inclusion, because in the heat of the moment, you can forget about it. So you have to keep pushing it up in your mind the whole time.
Now, you've shown that you are both prescient. Your time is come in all sorts of ways. I mean, not only because you came to science late, you came to genomics at exactly the right moment, and we now seem to be in the century of microbiology. So, Sharon Peacock, you are poised to take over the world, as far as I can see. So, what comes next? You've mentioned this interaction between the host genome and the pathogen genome. Just explain to us, if you will, where you think that's going and what you would like to see happen.
Yeah.
This is kind of a funding pitch, by the way, I must say.
Yeah, absolutely. No pressure at all. What I would say is it won't necessarily be me, but it's the people that I've trained and other people have trained who really are coming to the fore now in the next decade, and taking on what we have passed on. I think that there are perhaps two key areas that I would highlight. The first is this: I think we are at the verge of a new decade of research on the interactions between host genomes and pathogen genomes, together with very detailed metadata. All of the data is there. The complexity is bringing together this data and understanding it. So, 10 years ago, when I chaired a group that was considering how to address infectious diseases and the 100,000 Genomes Project, so there were 3 groups. There was rare diseases, cancer, and infectious diseases. At that time, it was like too early to think about human genomes, but now, because of the work of Genomic, ISARIC, etc., you can see how you can bring the pathogen genomes together with the human genomes and actually put them together to say there must be a chemistry between the two. So bacteria vary a lot, humans vary a lot. How does that interaction really work? So I think that's one of the new frontiers. I think the second frontier, of course, is the microbiome. So when I was first training as a microbiologist, it was an inconvenience when you were trying to plate something out on a plate and everything else was crowding in to hide the true pathogen you thought in that mix. You'd use lots of selective agar to get rid of everything else but the thing you were looking for. But that's so different because, we are a walking framework for a bacterial culture, basically. And that microbiome is so fundamental to our importance of, our immune system and so many other things. So I think that working out what the microbiome, where that fits in everything, and in any new areas, there's going to be a lot of noise, a lot of stuff that isn't quite on the money, and it's like sifting through what really makes a difference to how we treat people, how we stay healthy ourselves. That's going to be important. But it would be rather amazing if somebody comes into hospital one day and you can predict their response to various treatments, or even a GP surgery, predict how they could change their microbiome to improve their outlook on life. So it is an amazing time to be a microbiologist, actually. And I'm really pleased that I've seen that transition over the last 10 years. So bringing microbiology through, it's always been important. But now I think it's just so central to everything that we think about and do.
Should we take some questions from the audience? Any questions? They've all been struck down. They've all been struck down. But I've got another question, which is, so you mentioned legacy and you spoke of legacy. I mean, the whole SARS-CoV sequencing, COG-UK, it's all an extraordinary legacy in and of itself. But I suspect that, Sharon Peacock, you are going towards something even bigger and greater. What would you, and you now have a platform not only of the science, but also a public platform. What would you like to be your legacy in a wider sense?
Yeah. Well, one amazing legacy would be if every girl in the land thought about science as a career and thought that they could do it. When I was at school, I was streamed out at the age of 14 from doing chemistry, physics, maths, modern languages, because I was told I couldn't do it. And I think that if it's not just my legacy, but if girls actually think, based on the pandemic and all of those women and the women that we've highlighted and the women that have been highlighted elsewhere, that's for me. I really want to do that. Whoa, that would be incredible. So I would consider that a serious legacy. I also think that there's a lot of science left in me yet, and I'm just looking forward to the next revolution, which, as I've said, is just around the corner. So the thing with legacies, you're only accurate looking back rather than looking forward, and my crystal ball generally hasn't been that effective during the pandemic. So ask me again in 10 years.
We will. We absolutely will. I mean, you've done such a lot, and how has it left you feeling? Because COVID has been a kind of washing machine that we've all got into, and we've been thrown around. And how have you emerged from it personally? You know, is the Sharon Peacock of today different to the Sharon Peacock at the beginning of that pandemic?
I'm not the same person. I think that, first of all, I'm really proud of having done...
Yeah, we're quite proud of you.
Yeah. And really, and that's changed. I think I have a greater sense of what the science that I do and other people can really produce. And I don't think I really appreciated that before. It's not just about writing papers, although they're very nice, but it's about impact on the world. In terms of my life, I think that the pandemic has made me appreciate the small things, you know, walk and you know, the good weather, because many people have suffered quite badly, and I think that's really important. I think that being in the press was quite difficult, and that has allowed me to let things wash over me much more than I
and not look at Twitter every day.
I never look at Twitter. I got rid of my Twitter account because if you're in the public eye, and it's important that scientists are, and you know, Fiona Fox and what she's done at the Science Media Centre has been utterly brilliant. But if you go into the public eye, people start to recognise you. You get emails that are quite unpleasant, you know, including some death threats. And you know, you're sitting at the meal table with your husband and your children, and you open up your email and you see something like that. That necessarily changes you. But actually, what you have to do is just let it go, and it washes over you. So difficult days, I think. I don't really have difficult days anymore because, you know, I've just learnt to say, oh, well, you know, brush that off and just get on with it. So I think I have changed quite a lot as a person. I think that, although I suspect that everybody has changed as a person during the pandemic, I think whatever their situation, I think it's inevitable.
And is it true that 2 medical schools turned you down?
It was actually the same one twice. Yeah.
I thought about naming and shaming. No, we won't go there.
No, but they gave me a place in the end. So I rang them up. My husband said, just give them a ring. And I don't know what I was thinking, but I gave them a ring and said, look, you know, you don't know me, but can you just meet me? And to their credit, they met me. They gave me an interview. They said, write an essay on why you want to come here. And I wish I'd saved it, but I wrote an essay, and wherever that is. And 4 weeks later, I was at medical school. And so, you know, that university, they turned me down twice, but then they changed my life because they actually gave me a place at medical school, which just turned things around. Incredible.
I think it's magnificent. It's just such a wonderful story. It's wonderful science. I bow down before you, Sharon Peacock. I mean, really, it's so heartwarming to see somebody come from a part of their life that they perhaps thought that there was set in stone, and you've made it change. And not only have you made your own life change, but you've changed the lives of so many other people. It's all those people who work for you who now believe that as women, they can go and do magnificent science. It's all those people whose decisions depended on the work that you provided. Ladies and gentlemen, the magnificent Sharon Peacock, winner of the MRC Millennium Medal. Thank you. Do you know, all the things that I do for the MRC, sometimes I feel myself to be incredibly privileged. And I feel that tonight. I really do. I mean, Sharon, it's been wonderful. Thank you so much. So, there's more. There's even more in this wonderful bumper in-person event. And now we're going to go back a year to the 2020 MRC Millennium Medal, which was awarded to Professor Sir Rory Collins, and John Iredale is going to come and tell us a bit more about it and to give Rory the accolade in person that he deserved.
I don't want anyone to think that this is some sort of lockdown medal that's not as important as the one that you've had, Sharon. But it wasn't just that. I'm sure many of you joined me in hearing Rory's address online last year. It wasn't just that meeting in person was challenging or even technically illegal, or at least against sort of significant and rather austere guidance. It was actually that the Royal Mint wasn't working. It was physically impossible for us to commission a medal for Rory. So it's important that we take this moment to present Rory with his medal. So it's, again, an extraordinary privilege to be here. Rory Collins is the British Heart Foundation Professor of Medicine and Epidemiology and head of the Nuffield Department of Population Health at the University of Oxford. And he's, of course, as many of you know, Chief Executive and Principal Investigator of UK Biobank, that extraordinary venture which is now recognised the world over as being unique and vitally important for so many studies, not just in the UK, but as I say, internationally. Rory was selected as the 2020 medal winner by MRC Strategy Board and MRC Council by virtue of his outstanding contributions, particularly to clinical trials. It won't surprise you from his title, often in cardiovascular disease, as well as that really visionary leadership which has been so important to the establishment, development and success of UK Biobank. So I would like you to join me in welcoming Rory to the stage to present him with the MRC Millennium Medal 2020, a fantastic achievement. So, I'll pass back to you, Vivian.
So, there's more. So, a bit of a change now, because what we're going to do now is launch a new prize. It's the MRC Impact Prize for 2022, and we're just going to hear a bit more about it. Let's have a short video.
For more than 100 years, the Medical Research Council has worked to improve human health through world-class medical research, from fundamental science to early clinical trials and preventative medicine. MRC's long-term investments into structural biology underpins key discoveries of biological molecules. Our understanding of the flu virus and SARS-CoV-2 virus are all thanks to investments in this field. Cryo-electron microscopy is the result of nearly 5 decades of work by researchers working to find ways to explore the structure of intact cell components at near atomic level. Cryo-EM is already changing the way pharma companies approach rational drug design. In the fight against antimicrobial resistance, MRC-funded scientists work closely with researchers in China to influence the Chinese government to ban colistin, an antibiotic used to treat certain bacterial infections in animal feed. This unprecedented policy change has since led to a reduction in the spread of colistin-resistant bacteria. Researchers in Cambridge have developed a simple and inexpensive test called the cytosponge for the early detection of esophageal cancer. The test was developed thanks to decades of taxpayer and charity-funded research and is now rolled out across Scotland, costing just £25 and taking 10 minutes to administer in a GP clinic. The development of the Oxford AstraZeneca vaccine, the most widely used COVID vaccine in the world, was founded on years of MRC-funded research. And the COVID-19 Genomics UK Consortium, or COG UK, provided sequencing data that informed key public and policy health decisions made in response to the COVID-19 pandemic in the UK. COG UK used an open science approach that has influenced international SARS-CoV-2 pathogen genomic sequencing initiatives. All of these advances have been underpinned and enabled by a broad range of contributors. Whether it's using a team science approach to tackle the most complex research questions, or advancing open science to make research more transparent and accessible, the impacts made by MRC researchers truly change the face of medical science. The annual MRC Impact Prize recognises individuals and teams who make transformative impacts crucial to supporting advances in medical research, from scientific discoveries to improving the research environment and culture. The prize rewards impacts in 3 areas: open science impact, which recognises outstanding contributions to making research more accessible, transparent and reproducible; outstanding team impact, which celebrates an inspiring and successful team whose collaborative team science approach has made an outstanding contribution in medical research; and early career impact, which celebrates early career researchers who have made groundbreaking impacts in areas that are critical to support future scientific advances, such as improving research culture and environment. Winning entries will be presented with a financial award of up to £20,000 to further the learning and development of the nominees or to further disseminate the impact. Nominations will open on the 23rd of May 2022 and close on the 29th of July 2022. To find out more and to submit an organisation nomination, search MRC Impact Prize or visit the MRC website.
So there you are. And the key thing to note there, nominations open on May the 23rd and they close on the 29th of July. So I do hope that all of you will tell your teams about the MRC Impact Prize and encourage them to apply. Could I now introduce Professor Dame Liza, who's the CEO, as you know, of course, of UKRI, to tell us a bit more about the MRC Impact Prize.
Thank you very much, Vivian. And it's really a joy to be here. As you said, it's great to be back in rooms with real people, and particularly on an occasion like this, that's such a wonderful celebration of everything that this community is about. So I'd like very much to add my huge and warm congratulations to Sharon and Rory for their fantastic achievements. And they're just a credit to this prize. They represent everything that this prize is about. And it's not only their outstanding contributions to science, but also their extraordinary leadership and service to the wider community. And that's very much what these new prizes are about too. And I think that's so important. At the moment, we live in a time when research is rewarded, in my view, very disproportionately on a very small number of criteria. So your publication record and maybe your grant funding record. And those things are important and they recognise key things that we need to do as researchers, raise money for our research and publish it so that people can read about it. But they are only 2 of the things that we have to do as researchers, and they are only 2 of the things that are important for the research and innovation system to thrive. And not only do I think we disproportionately recognise those things and not recognise the wider range of things, but also we are very obsessed with individuals and their individual contributions to those 2 things. And the result of that for the research and innovation system is quite problematic. I think it's problematic because we then undervalue and don't spend enough time or thought in that much wider range of activities that we all need to do, and because it puts extraordinary pressure on individuals to deliver as lead authors or as lead applicants on those grants, when we know that exactly the kind of exciting science we've heard about tonight relies on a very wide range of people with very different backgrounds and different perspectives and different skills, and all of those people are essential to take the research forward, but all of those people are not valued and rewarded in the same way. So I think that maps onto yet another theme of tonight, which is this question about diversity and inclusion. If we have a research and innovation system that values a very small number of things and requires all individuals to deliver that very small number of things, inherently we will be crushing diversity in the system. So to me, this question of shifting the reward and recognition system in the research and innovation system is absolutely crucial. And I'm very excited about these new MRC prizes precisely because they do exactly that. They recognize and reward that team science element that we talked about. They recognize and reward open science, sharing your research and outputs openly beyond just the paper, but also the database, the software, all of those things that are so important to everybody. And they recognize the contributions of early career researchers, not only to delivering outstanding research and innovation, but the key role that that community plays in building the kind of healthy, creative, supportive, collaborative environment that we know is essential for the success of the system. So supporting that diversity and recognizing the full range of things we have to do has been absolutely key for me in coming into this job nearly 2 years ago now. It's one of my main drivers for taking it up, because I've seen over the years how antithetical to everything we're trying to achieve this disproportionate value on a small number of things with a huge pressure on individuals has been. So this kind of initiative, I think, is key, and it's part of a whole range of things that are going on across UKRI to try to shift the incentives in the system to create that more creative and collaborative environment that we know we need. I'd like to highlight just two of them. One is the resume for research and innovation. It's a narrative style CV where we are asking all the applicants for our grants as we roll this out across the piece, not just to list their publications and their grant funding, but rather to provide information on the discoveries they've made, which they can evidence using those things, but also information on the support for others in the research and innovation system, their mentoring, for example, which they can also evidence in a wide range of ways, their contributions to the wider research and innovation community, organising conferences or whatever, again, huge number of things you can evidence in that category, and their contributions to engaging with wider stakeholders, for example, publics or patient groups. Those four things you can describe very easily, and you can evidence very strongly. And it's not that everybody has to do everything, but we think everybody can do something in each of those categories and provide strong evidence to support their contribution, and that will really highlight the crucial role that every researcher plays and everyone we want to fund needs to play in helping the entire system thrive. So that's the first one. The second one is maps very nicely onto the Women in COG initiative that Sharon described. We are running a thing that we call the 101 Jobs That Change the World campaign. I would strongly encourage you to go and look at the little videos on our website. And what they are is maybe, in the end, 101 little videos of people making vital contributions to the research and innovation system who would not label themselves as researchers and innovators. So they are the technicians, the administrators, the IT specialists, the communications specialists, all of these people without whom none of this would happen, but who don't currently have the same place in the system, the same reward structure, the same opportunity to showcase their key contribution that researchers and innovators have. And so I think these new MRC prizes are just perfect from the point of view of stressing exactly these same points, and they map very clearly into the next phase for us at UKRI. You may have seen we've just launched our first ever 5-year strategy. We have finally a multi-year funding settlement, which we've never had before. And through those opportunities, we hope to be able to drive changes through the system, supported, co-created with you. And those changes, we think, are underpinned by three key principles for change, one of which is diversity. Without diverse people, diverse ideas, diverse approaches, diverse motivations, all of those things, working in diverse places with different, we need all of that diversity to come together, because it's through that diversity that we get that creative spark and the difference and the innovation. And to get the benefit of that diversity, we need not just diversity, but connectivity. All of that diversity needs to be connected up, and we don't think hard enough about how we invest in connectivity. It doesn't seem like a thing, but it takes huge amount of time and energy, as we've heard from Sharon. Bringing people together in the right permutations and combinations is crucial, and that takes work, and we have to think about that and value that and invest in that. So diversity with connectivity and collaboration, and from that you get much more resilience in the research and innovation system that we also need to think about, ensuring that we fund across the piece in a way that supports that resilience. And that entire system then needs to be much more deeply engaged in wider society. So that's our fourth principle for change, and that's engagement, to make sure that the walls between what we're doing and wider society are taken down so that people come into the system, our ideas go out into wider society, and it's much more embedded. And those things, all of these things and these changes, we have, I think, the opportunity from the disruptions of the pandemic to bring forward, because all of them are so beautifully illustrated in the success stories that we've heard so much about today from the pandemic. They're there in front of us. You can see what we can do if we work together in this way. And I'm absolutely delighted that these new impact prizes from MRC reflect that. And I'm very much looking forward to this time, maybe next year, when we get to meet the prize winners. Thank you very much for coming to celebrate this wonderful occasion with us, and I hope you enjoy the drinks.
Thank you so much, Rosaline. And could I now ask Professor John Ardell to come and conclude our ceremony?
Thank you very much, Vivian. Just by way of concluding, of course, it's important that I thank a group of people that have put a lot of effort into making this evening run smoothly in the way that it has. I just wanted to recognise that I personally have had an extraordinary time this evening. I hope that you, like me, have appreciated the enormous interest and excitement that the MRC Millennium Medal competition generates. I referred to how Sharon was identified as the winner from an extraordinary group of individuals who were nominated, and I think that we need to recognise that in itself is a reflection. It attests to the strength of UK health and life sciences, a group of individuals, a group of groups, a group of teams, a group of international endeavours, as well as national endeavours, that it's really important that we continue to support. I think it's been a wonderful evening reflecting on the strength and importance of our research environment and our research culture. Looking to the future, you've heard from Vivian, you saw the video. Ottiline, thank you very much for your words as well. I think these new MRC prizes are going to be really, really important to us. They will add to our portfolio. And of course, next year, in addition to those three new prizes, we will be awarding a further Millennium Medal. And of course, we also have the Max Perutz Prize for Scientific Writing, which is a major award that the MRC makes to PhD students. And I know from speaking to individuals who've received that how important it's been for them. So I would direct those of you in the audience who might be in a position to suggest nominations to have a look at your brochures or go online to look at these competitions, and do please seek to prod, push, identify, sponsor, put forward, nominate suitable individuals for each of these really important competitions, because we're all really excited by it and we're all really looking forward to seeing some fantastic applications next year. Now, I was told I wasn't to go off-piste with my script, but I'm going to for one or two sentences, and that is just to reflect my personal view on the quality and the strength that we've seen this evening. And I want to phrase this very simply, Sharon, and Rory also. You used the term privilege. You said it's been a privilege. On my behalf, and I hope many other people in the audience, I think truly the privilege has been ours. I really do. Thank you very much. As I say, it's very important that we thank a group of individuals who've put a lot of time and effort in making this work. Vivian, thank you so much for being our superb Master of Ceremony.
Pleasure. Most
appreciated. Once again, Sharon and Rory, thank you both for coming, and thank you for your excellent presentation, Sharon. And, you know, what two wonderful Millennium Medal winners. I'd like to acknowledge all the effort that went into those nominations. You know, it's a serious job, and publicly thank the nominees and the nominators. The MRC Prize Committee, which we set up this year with this new panoply of medals and awards, and those members of Strategy Board and Council who, in the previous iteration of the process, played such an important role in sifting through the applications and coming to a decision about who should win the medals. Sarah Trenfield and the Strategic Engagement team, thank you very much indeed. I have to give a really special shout out for Sarah Brygan. Sarah arrived at the MRC in the midst of a pandemic and successfully put together the online structure of Rory's lecture last year, and put together and worked from the MRC side to bring this evening to fruition and to the stage of superb, seamless effectiveness that you've seen this evening. And then Sarah got COVID. So poor Sarah is at home and watching this online. So Sarah, my message to you is do please enjoy that glass of chilled Prosecco. It is thoroughly deserved. Deborah Barber and the UK Comms team, thank you also very much. Jessica Ladd, Morgan Crumby and the MRC Events and Committees team also, thank you very much indeed. And I would also like to thank our friends and colleagues at the Royal Society, the team and venue colleagues who have assisted us by the sort of infrastructural and catering organisation. So that's enough from me. There will be refreshments. For the final time, Vivian, I hand back to you.
Thank you. So I'm going to just talk to all of those people online, many of whom I suspect work on Team Sharon. Now is the moment to crack open that glass that probably you may have started already, but continue to enjoy it. For all the rest of you here, it's time, and isn't this wonderful to say, we can have drinks and canapes and mingle. Thank you for being with us. Thank you for taking part in this wonderful celebration of two great people, and Sharon in particular. Thank you.
Thank you.